Okay, our transformation rule today is talking about rotations. Your essential question is, how do you identify a rotation rule and how does it affect the graph? So please make sure you write that down, get your notebook set up, and pause the video as needed. Okay, so the first thing that I want to mention about linear rotations is that this is a multiplication rule. This is a multiplication rule. Okay, so we know translations, the rule was adding or subtracting. Reflections was simply multiplying by a negative. And linear rotations is a multiplication rule, and you multiply by a positive number. If we throw in a negative, then we are adding in a reflection as well. Okay? So the first rule, we have f of a times x. The first thing I want to tell you is, remember, the a could be a different letter. It doesn't have to be a. But what that a represents, the a just represents the number to multiply by. The number to multiply by. And so I hate that this keeps doing this. Okay, so this rule is inside the parentheses. So because it's inside the parentheses, this affects the x. Right? And so because of that, we will end up multiplying the x term. So when I say the term, that's going to include the slope, right? The x term by the a factor, whatever the a value is. Okay, and that'll make sense in a minute, but I want us to write this down. What we're going to notice is that the steepness of our line is going to change, and it could get steeper or it could get less steep, but it's going to change. We're going to see that our y-intercept is going to stay the same, but our x-intercept will change. Okay? This particular rotation, this particular rule is a rotation on the y-intercept. So it's kind of like our pivot point. It's like our point that we're taking, and then everything is shifting around it or rotating around it. Okay, so let's just look at an example for that and see if all the things that we said are actually going to be true. I actually think rotations are an easy rule because it's multiplying. It's super easy. So here we have function f, 2x plus 3. Let's go ahead and graph that. Our y-intercept is 3. Our slope is 2. So up 2, right 1, down 2, left 1. Okay, here's function f. Now, really important is we've got to figure out what needs to change. So this affects our x, and we said the x term is what needs to change. So when I write my new function, g of x, we're going to, our factor is 3, so we're going to say 3 times 2x, just the 2x, and then plus 3. So our new function is going to be 6x plus 3. That is our new function. Okay, so let's graph it. So y-intercept is 3, now our slope is 6. 1, 2, 3, 4, 5, 6, right 1. 1, 2, 3, 4, 5, 6, left 1. Okay, so there is function g. Now we know that we need to describe our attributes. So let's see what happens to the slope. Again, you should be able to tell this just by looking at the equations. So our slope went from 2 to 6. So this slope is steeper. The slope got steeper. The y-intercept, 3, 3. And we said up top that it was going to stay the same, right? So the y-intercept is the same. And then the x-intercept, we went from the blue to the green. It looks like, you know, it moved to the right. So it's kind of hard to tell exactly where it is. So we could just say that it changes. Or we could say that it moves right, because we can indicate that. You can't necessarily tell that it moves right just by looking at the equation, but if we're taking our line, let's try, I know my pen's a little bit thicker, but if we're taking our line and rotating it, and that pivot point is our y-intercept, then we know that that x-intercept is going to change, right? So I'm sorry, it's kind of hard to see with my big fingers and my little screen. Okay? Okay, so the other rotation rule is just that it affects the y instead. Okay, so let's write down the effects that this has. So this time, this affects the y, or the whole equation. So this means we have to multiply the whole equation by our multiplication factor. We're going to see that our x-intercept stays the same. We're going to see that our y-intercept changes, because we're changing the whole equation, right? So that would make sense that the y-intercept would change. And you're also going to see that the steepness changes. Yeah, and it can be steeper or less steep. This rotation is a rotation on the x-intercept. It's a rotation on the x-intercept. So the x-intercept is our pivot point. Okay, so let's look at this. Let's graph function f. We have a y-intercept of 6. We have a slope of -2, so we're going to go down 2, right 1, down 2, right 1, or up 2, left 1. Okay? Now, if our multiplication factor is 1/2, can you predict what's going to happen to the slope? I hope you're thinking, well, if we're halving the slope, isn't that going to make our slope less steep? Okay, so let's check that out. So this is affecting all of y, so our whole equation. So to get our new function, g of x, we're going to say 1/2 times -2x plus 6. Last time we just multiplied the x. This time we're multiplying the whole entire equation. So this 1/2 times -2 is -1x, or you could just put -x, same thing. 1/2 times 6 is 3. So our new function is g of x equals -x plus 3. Okay, so let's make some predictions without graphing it, and then I'll graph that in just a second. So our slope went from -2 to -1. So our slope is less steep. Okay. Our y-intercept went from 6 to 3, so it went down 3. And then our x-intercept, what do you think is going to happen? If this is a rotation on the x-intercept, that means it's going to stay the same. Now, how could you figure that out? If you didn't realize that, if you didn't remember that, all you have to do is type in each equation to your graphing calculator, Desmos, or whatever else you're using, and you would see that the x-intercepts stay the same. That's why we're drawing the graphs too, to help us interpret what's happening. So use those calculators. Once you have your new equations, you can type them in and it'll be super easy. Excuse me. So let's just check. So we got a y-intercept of 3, a slope of -1. Down 1, right 1, down 1, right 1, down 1, right 1. And so we can see right there, there's our pivot point, that our x-intercept stayed the same.